I see my timer starter approaching. Uh-oh. It's getting real. Is it now? We're on. We're live. All right. Welcome. Welcome, everyone, to this session, this first morning session. I'm so impressed that there are so many people here already. Thanks for coming. I'm Mads Torgersen, not Christensen, as I discussed a little earlier. I work on the C# language. I run the design team and sort of help concoct the next version of C# at any given time. I'm on a team with the people who build C# and Visual Basic and F#, the compiler, the IDE support for those languages. And you are here to hear about C# 6 and Visual Basic 14, I hope. And that's what we're going to dive in. We have a pretty good amount of time to go into good detail here. So I want to do just a little bit of background, and then we'll spend most of the time in Visual Studio diving into the features. I want to say that I'm happy to take questions along the way. I'll probably stop at every feature or two and ask for questions. It's best for the recording and the live stream, if there is one, to have you come up to the mics and ask the questions. Okay, so there are 4 mics as far as I can see. Come up there and ask questions, and I'll try to be good at getting to you. And I'll also let you know if we're running low on time and I kind of have to cut some of the questions off. But it's easier to ask a question when you think of it rather than at the end when the context has shifted. So I'm happy with that. All right? What I'm going to talk about here is essentially, there's a little backstory to it. We essentially came out a year ago starting to talk and show about C# 6 and Visual Basic 14. We had clicker. There we are. We released what we call the .NET compiler platform. Essentially, the C# and Visual Basic compilers, we released them open source at that time. We went out on CodePlex first, and we shipped some previews with that included new language features, new IDE features, and so on. And since then, we've been churning on the language features based on previews, many previews that came out, and feedback from people, and so on. And this feature set that we ended up with that's now in Visual Studio 2015 release candidate is somewhat different from what we showed a year ago. But we've taken that whole journey in the open. And I'm really struggling with this clicker here. We also recently released the .NET Core runtime and libraries, open source. They're on GitHub, and everybody can participate, and a lot of people are participating from outside Microsoft with pull requests and so on. And that journey of open source was supplemented by, where is the receiver for this thing? Where should I point it? I should just go click the keyboard, shouldn't I? We moved what we call Project Roslyn, the C# and VB compilers. We moved those from CodePlex to GitHub, realizing that's sort of where the action was. And we also took all the other C# and Visual Basic related source code, and we put it up as well. So not just the compilers, but the IDE integration and all the whole stack that's specific to the languages. So we now strongly open source. So I do mention this Project Roslyn, and that is sort of the background for a lot of what we've done in the language and around the languages, which is essentially about taking the C# and Visual Basic compilers, that is the parts of our code that understand source code, taking those and rewriting them in C# and Visual Basic. They weren't open sourcing them and putting a rich API on top of them that offers up that deep understanding of the language to anyone who wants to use it, a public API. And then we built our own IDE completely on top of that as well, so just to make sure that it's rich enough and strong enough. If we can build our IDE experience on it, everybody can build something nice on it. And that's a great story for people to plug into Visual Studio now, or into the compiler pipeline, using that model, object model of the source code to provide their own analysis, their own fixes in the IDE as well, in a fashion that's indistinguishable from what the IDE itself does. So you essentially have language level easy extensibility. So that was one of our core goals here. Now, also having moved to a new, better source base, unified source base for C# and Visual Basic, this was also an opportunity for us to do some language innovation and add a bunch of new language features. And that's, of course, the focus of this talk. But I wanted to give you this background. And if you look at this, I wouldn't call it a diagram. It's like 4 words in boxes. But the IDE, the smarter IDE experience, the refreshed IDE experience is the topic of a talk tomorrow by Dustin Campbell, I believe in the next room at the same time. So go watch that as well if you're interested in that. Click. So I'll talk about language features. C#6 and Visual Basic 14, we did not say, OK, let's go change the world again. We did that with async. That was very much a very foundational, concept-heavy feature, if you will. It takes a while to wrap your brain around, like I haven't really yet. It's very, very useful, but also has a large impact on how you should structure your code base, how the rest of your world around you is structured, and it alleviates a big problem, but it's also heavy machinery. So we wanted this time to take sort of a light sprinkle tour through the languages and put things in that should be useful to you every day, but are little and light in concept. So that's what we're doing. There's a lot of features, depending on how you count. It's between 10 and 15 new features in both C# and VB this time around, but they're not big features. They just change how your code looks, not so much how it works under the hood. Okay? So we'll just go and look at all these features and go into details. We have time to go into detail. We'll look at both C# and VB, and then time permitting at the end, and I'll try to permit it, let's take a look at what we're thinking beyond the C# and VB that is about to come out with Visual Studio 2015. That's very preliminary, but I just want to give you a sense of the openness of our language evolution and the evolution of our whole platform, and how easy it is to participate in and kind of look at us while we're making the sausage, if you will. It's very different from what it's been in the past. It makes it harder to show up at a conference and pull something out of a hat and see what we did. But it's also very nice to have continuous feedback and continuous participation of the community. So that's background. All good? Ready to start? Let's see if, hopefully I don't have more slides then. No, this says demo. That was good. OK. Yep?
Just one stupid question. What version of .NET is required for C#6?
Great question. What version of .NET is required for C#6? The only version required is .NET 2, as always. OK. C#6 and Visual Basic 14 don't really have hard requirements on the frameworks. They do expect certain types with certain names and a certain structure to be there. For instance, the async feature relies on things having a certain shape in order to be able to use them as tasks. It relies on something being there that's called task. But that doesn't mean you have to have .NET 4.0, which introduced task. It just means that when you use that feature, there better be something that has the right shape that the compiler can use. Otherwise, it will compile errors. But it's not a strong dependence on the framework. It's a dependence on patterns in libraries. Okay? You can just steer around the features that use APIs that you don't have, and it'll work fine. I hope. That's at least the intention. Okay? Good question. So I want to just start right out with a very simple feature. Let's look at this source code here. Maybe some of you have seen it before. We've used it to death. We actually only tested anything we do on a point class. That's the new RAD style that we're sort of subscribing to now. And all the program does is to create an array of a point class that we'll look at a little more. We could actually compile and run this thing once. But otherwise, I'm not going to run much code here because we're really just looking at syntax and compile time behavior. So print out a list of points, convert it to JSON manually, then use JSON.NET to convert it automatically, a list of points, write that out, convert that back to points, and write it out. And that just gives me an opportunity to show some different things in the code. It's just an excuse for things to get going. So the first feature I want to show you, actually, let's ask right now, how many people here are C# users? Okay, that's like about 5%. How many people are Visual Basic users? Okay, a good number. Yep. How many people are F# users? Just for completeness? Yeah, we have a few. Great. Welcome. How many people are none of the above? Okay, so everybody here will feel familiar in a .NET language, and most will feel familiar with C#. I'm going to show both C# and Visual Basic, but I'll stay mostly in C#. So something that Visual Basic already has, pretty much, is the ability to, a new kind of, we'll call it a using clause here in C#, in VB, it's imports, the ability to import a type instead of a namespace. And when you do that, it's called using static. So let's import, for instance, system.console. What happens is that we're importing all the static members of that type directly into scope. Okay? So VB users are like, huh. What that does is, if you look at the IDE here, it's now graying out all my occurrences of console. In console or write line, it's saying you don't actually need to say console because write line is directly in scope. And so you can go and actually there's a refactoring here that will simplify it for me and just let you write write line. And this and other refactorings in the code here actually can be applied across all occurrences. So that's it there. So static members, oftentimes, so this is an example of you have a static class which has some function members in it. Another common example would be using static system.math, right? That's just a bunch of static functions. And if you're doing a lot of math, right, trying to write out a formula, you have nice terse operators like star and slash, and then you have to say math dot with every other operation you do. Now you can just import it and just call square root and whatever. Actually, I have an occurrence of square root down here in my code somewhere, so we can see that's grayed out. We can just go and say forget about that, and it'll just let you call square root here. So that should be a nice sort of simplifying thing for you. It goes a little further also here, where you can, for instance, do enum members. So using static system.day of week, you can do that, and now you can say Monday instead of day of week.Monday. Okay, nice. It is also a feature that is a little dangerous because, so use it with care, because it introduces a lot of names directly into scope that maybe were not designed to be introduced directly into scope. Okay, so an example of that I'm actually also using in this program is if we take Newtonsoft.json.link.jtoken type, for instance. You know, that's something that talks about which kind of thing is inside of this particular JSON object. Like, is it a string or an integer or whatever? And of course, it introduces names that clash. So you can see we have red out here because it introduces something called string that clashes with the system type string. Now, we could fix that in this particular program by saying using static system.string and import all the static members of string, and then down here, instead of saying string.format, we could just say format and never use string anywhere. But that's, of course, I'm just doing that to show what you can do with the feature. I wouldn't actually recommend going down this path. Don't introduce a lot of things into your namespace if they're clashing, of course. So let's actually undo that bit. Get rid of, let's just delete that here. Okay. One more thing that might be interesting around the using static is how it works with extension methods. So I want to go and use static system.enumerable, system.link.enumerable. Do you guys you guys know enumerable. That's the one that introduces the query methods into scope, the where and select and so on extension methods. The one that pollutes string with hundreds of methods when you try to complete something on it. And let's actually go and remove the using of system.link here. So what that does is it does bring in all the static members somehow, but for all the ones that are extension methods, they're not brought directly into scope. So this does not mean that I can all of a sudden just say where blah, blah, blah. Where is actually not in scope, okay? Because it's an extension method. It does bring it in as an extension method, and so you can see the queries down here, which rely on where and select methods, they still work. Because so this is a way that people have actually asked for since we introduced link and extension methods to take just the extension methods from one class and not all the ones from a namespace. You can do that with using static. Okay, just brings in the enumerable ones in this case, not the queryable ones that are also in the system.link namespace. Does that make sense? All right, that should be useful. But it does bring, of course, in the methods that are not extension methods, it still brings those into scope, obviously, like the features intended. Okay? Any questions on that?
Can you give the type a name?
Can you give the type a name? You can still do that. Already exists in the language, being able to do a using alias for a type. So you can still do that, but not in the same using clause. You have to do a separate using alias for that still. Okay. All right. That was an easy one. Now let's go talk about auto properties. So automatically implemented properties, as I believe the official name is, though nobody ever says that. Auto properties are great if you implement. So now we're going into the point class here itself and starting to look at the different kinds of things we've done around member declarations. So auto properties are great if you happen to want mutable properties because they have a getter and they have a setter, and that's how they're supposed to be. That's how they were originally designed. But it's really annoying if, like in this case, you want your class to actually be immutable. More and more people are opening their eyes to using immutable patterns in the code. Immutability has a lot of benefits to it. Of course, on the surface, it seems like it's allowing people to do less. Why, it's preventing them from assigning. How can that be good? But it really is good because if you share an object, you know it's never going to change, right? You know somebody else can't change it under your feet. You can rely on it retaining its shape. We use it extensively in that object model, the Roslyn object model that I talked before of C# and VB code. Every syntax tree in there, every data structure you get describing the source code is immutable, okay? It sounds a little strange because it's representing what you're editing, which changes all the time. But what happens is you get a new tree, a new model, every time a single key press happens. And that has enormous benefits. It means that, first of all, it means that we can have two versions of the world at the same time, so that if we do a refactoring, we can show the before and the after at the same time. We have just two versions of the world. Of course, we're making it efficient under the hood by sharing a lot of structure. It also means that we can we can use a lot of concurrency when we compile. So in a compiler pipeline, we will use this extensively to be concurrent over the data structures that are there. We know there's not going to be shared mutable state that is going to mess things up or require certain orderings or require locking or whatever. And so once you get over not being able to change things, it's really great to be immutable. All right? So we think that applies to a lot of things. We want to make that easier in C#, to make a long story short. And so here, instead of having to now declare my own read-only backing fields and access of properties for it, I can now just declare a getter-only auto property. Okay? Just say get semicolon. Instead of it being much longer than the immutable version, it is now actually shorter. It's got like fewer characters, right? So now I have getter-only auto properties. Those are backed by read-only fields, just like I wrote here. They're just implicitly generated. And they can still be initialized from the constructor It can be assigned to in the constructor of the type, just like the read-only fields, just like read-only fields can. And then they're read-only from then on, once the constructor has run. So I can just write it like this and get rid of my explicit backing fields here, right? So no more. This is no longer an excuse. No more writing mutable code where you could make it immutable. The syntax supports you now. Okay? It's good? Good. This is one that Visual Basic also has. So if we go to the Visual Basic version of this code here, you'll see that you can now say public read. You can say read-only property, and that has that same effect, which wasn't in VB before. What has been in VB always is the ability to initialize a property directly as part of its declaration, an auto property, and we have now added that to C# as well. So on these auto properties, if you want to initialize them with an initializer, you can do that just like you can a field. Okay? So useful? I hope so. How many people ever use auto properties in practice? Okay. Okay, it's going to be useful. Good. How many people use immutable patterns in their code, I wonder? Okay, not so many. Okay. I would say, was that 5-10%? Do it more. We have a great library out now called, what's it called? Immutable Collections, that has immutable versions of a lot of the collection types that are in the framework. It's a NuGet package. It's really good. Look at it. Okay, so I'm actually going to remove this because I don't want to initialize it to 5. But there you go. So those were the auto property features. Any questions? There's one here. You can shout it and I can repeat it. It's a little hard to get to the.
So without a setter, does that mean that we only have the magic to set that in the constructor?
Yes, in that initializer or the constructor. And what they do is that's a good question. The magic to set it, you can only set it in the initializer or the constructor now. And what it actually does, there is no setter, so it doesn't call a setter, it just assigns directly to the backing field. The compiler knows, even in the constructor here, the compiler knows that this is an auto property with a backing field, so it knows to just generate the code to assign directly to the backing field. Okay? So it's really just like read-only fields, but for properties. That's how we designed it. So one more question here.
So can you state those with the object initializer syntax?
Can you cannot use object initializer syntax for these because object initializer syntax requires there to be mutability. It creates, you say new object and an object initializer, it creates the object first, then assigns into the properties. So that's too late. Now that is something we would really love to do, but we're not sure how to do it. So that is one of the things that we have sort of vaguely touched on for maybe the next version of C# and Visual Basic. Is there a way we can make object initializer syntax work on immutable types? And I think there probably is. We just have to choose the right pattern for it. That's a great question. Yes, we'll take one more there.
There has been a performance penalty for using read-only in the past. Does this eliminate the performance penalty for read-only?
There's been a performance penalty for read-only? In
Read-only variables or had a slight performance penalty over.
Oh. I didn't know that. I didn't know there was a performance penalty for read-only variables. That's a strictly runtime thing, though, if there is. The code we generate is the same, except we put the read-only flag on it. So I can take that and find out if if there is a penalty there. If there is, it's small. But this would have the same penalty. It's simply, we generate the same code as if you had written the backing field yourself. When we generated read-only, it seems a little like, why bother? Because nobody can get at the backing field anyway. But there's still ways to look at it with reflection and so on. We kind of just want to have the right metadata in there. Or people look at it from other languages that don't filter out those names. So, okay. I don't see hands. Good. So let's move on from auto properties and talk about other member declarations. So one thing that we also see a lot is that folks have a lot of methods and properties that are excruciatingly simple and where the logic kind of drowns in the ceremony of writing the method or property in the boilerplate that needs to be there. And we want to do something about that. So if you look at this toString method here, for instance, it's a method that just has a single statement in its body, which is a return statement. Okay, so if we stop and think about lambdas for a second, when we introduced lambdas, we were like, oh, we don't want to bother people with having to always write statements in their lambda body. Why don't we make a version of lambdas where you can just put an expression after the arrow, and that just means the same as if it had a statement body with a single return statement with that expression in it, right? That makes sense. So why not do that for declared members as well as for lambdas, for declared function members? So that's what the next feature is about, and it is appropriately called expression-bodied members, okay? Because a member can now have an expression body. And what you'll see is a funny thing here. The IDE is actually suggesting to me to use an expression-bodied member, okay? Why is it doing that? This is not built into the IDE. This is one of those Roslyn analyzers that I have installed. Actually, Dustin, who's doing the talk tomorrow, he created this analyzer. He's recognizing a pattern in the code with his little plugin saying, you might want to consider changing this to one of the new language features. He has a little package of analyzers looking for opportunities to use the new language features. And it will fade these things out to tell me, there's something you might want to consider here, something you don't need. And here's a fix for it. Use an expression-bodied member. So his logic that is plugged in to the IDE, this simple logic you could have written, it's showing the before and after just like a built-in, because he created a new syntax tree from the old syntax tree, both immutable, and they're both showing up at the same time here. The IDE knows how to do the diff, color the one thing red, the other green, show it up in a preview here. So it's already run the fix that he's written so that it can show the result in a preview. And all that happens when I click Use Expression-Bodied Member here is that syntax tree is now put in as the official one that backs the buffer here. So when I do that, what you see, it jumps a little here, what you see is that the toString method now changed into this shape here. So what's going on there is that the arrow that most of us probably think of as the lambda arrow, but which we should now start calling the function arrow, because this is now no longer in lambdas, that's how you can see that there's an expression body following. If we didn't put that in there, it would be a little odd. So like we would have all kinds of conflicts in the syntax. So, yeah? So that's an expression-bodied method right there. You can do it with other kinds of function members as well. I have some operator overloads down here. They're also great candidates. And I do want to look at the property here. The sort of common case for boilerplate and properties is that you have a computed property that is a getter-only property without a backing field. That sort of computes its value every time. Okay? That has a getter body with a single statement with a single statement that is a return statement. So for these, we decided to go a step further and say, let's not just do something with the getter and make that simpler. Let's take the whole property and make it simpler. So what you do is simply to, I don't like that it jumps like this, is to simply just take the whole getter body and all the curlies away from the property. So the property really just gets reduced to a name, an arrow, and an expression. Okay? The getter is implicit, it's implied. And that takes a little getting used to. I don't think there are other properties that are getter properties that don't have the get keyword in there, but we thought that the savings here were good. The way you can tell it apart from the expression-bodied method is that it doesn't have a parameter list. It doesn't have parentheses. Okay? I see a question here. Can you show that in VB? I cannot, because we decided not to do this feature in VB. We played around with it, and it felt like VB was a little too statement-oriented. C# is a little more expression-oriented, and so the syntax we could come up with didn't feel good. So we decided to punt on it for VB. This is a C# only feature. Okay. I hope the applause was for the feature and not for it being C# only. So it was one that didn't make sense for VB, we felt, after having played with it. Hey, if we can come up with something good there, we'll do it in a later version, I think. It's just, this didn't feel right. So you were there early?
Is this just for the code cleanness, or is this also having a performance impact?
Is this just for the code cleanness, or does it also have a performance impact? It does not have a performance impact. It generates the same code as what you saw before. It's syntactic sugar of the sweetest kind. There's a question here. Was that the same?
That was my question.
That was your question, too. OK. Hand there. Is this considered the best practice because it makes things very terse? You have so much going on. It is considered the best practice if it feels right. Okay, it's an option. I think this is probably one that companies will have policies around, or development groups will have policies around. When is it appropriate to use an expression-bodied member? And hey, you can write a Roslyn analyzer to enforce that policy and to help people adhere to it. Let's actually try to convert these two, because that kind of makes a point. See, if you choose all and document, you get a preview here. Now you see the sort of cumulative effect of doing it for a lot of function members gets a lot of your code on the screen at the same time. That is terse, and you may like it or you may not. But it did just reduce like a whole screen full of code to essentially 6 lines here, including empty lines. So that's a trade-off you have to make. I think don't use it. So I guess here's what I would probably consider the best practice. Don't use it if the expression is too complicated, right? And in particular, well, and especially don't use it if that expression has lambda expressions in it, because then it's just crazy. But in particular, do not change your statement-based logic to be expression-based just so you can do this. Okay? Don't go overboard. I can make it a single expression if I use the ternary operator 3 times, and then I can make it an expression body method. There will be people who are tempted to do that just because it's fun, and then you look at the code and it's APL. So don't do that. Okay, let's take one in front here.
The analyzer that ships the latest version of VB works this way. Does that sort of mean it's going to become for many people the default behavior unless they specifically change it?
You're saying the analyzer that ships? If the analyzer that ships with the languages, if it encourages a specific behavior, isn't that what people are going to do in practice? Yes. And that is why the analyzer I'm using here does not ship with the product. It's one. So Dustin wrote it as if he was just anyone wanting to write an analyzer for their own use and to share with the world. And so he put it up on his own GitHub site and on the code gallery, the VS Code gallery, and people can just download and install it if they want. An analyzer is either you can compile it either into a V6 that works across, and that you can enable across all your projects and all your development, or as a NuGet package that you can download and reference in a particular project. And typically, the latter will be used if the analyzers and fixes are about how you use a particular library. You can then ship them with the library, and the people who use the library will use it right, because you wrote executable guidance that comes in with that library. So this is not default behavior. What I'm showing here, you can get it very easily. If you have VS 2015, go to Dustin's, go to the code gallery and find this. It's called C# Essentials, and it just has 4 or 5 analyzers that suggest the new language features in certain situations. So if you want to play with the new language features, it's a good way to discover where they apply. Okay? I think I saw one more question. Maybe that was the same question. Okay. One more over here. Okay, yeah, no, it's not shipping with 2015, but analyzers don't have to. We do ship a set of analyzers that are essentially equivalent to not all, but the most useful and appropriate FXCOP rules. So those are shipped by default, and you can turn them on. You can turn an analyzer on and off if you want to. I think that one comes in the box. The trick with that is that FXCOP runs as a separate build step, and it tells you long after you wrote the code, oh, you probably shouldn't have done it like that. Now go and change all these 100 lines of code where you copy-pasted a lot. But an analyzer is live. It does it on every key press, right? And so this is a way for that kind of guidance to be much more at your fingertips, if you will. C# Essentials, I believe. I think we should probably pull... Hey, Dustin is over there. Look at him. Look at his T-shirt.
So if anybody is interested, come to my talk tomorrow.
Yes. I did plug it a lot. Did you show up late? Okay. He just likes more attention. It's good. Come to his talk tomorrow. Don't be here today. Come to his tomorrow. But let's take this back to the language. Dustin is going to talk a little bit more about the analyzers and fixes because they're part of the IDE experience. Even though I don't think either of us will get into how you actually write them. It's pretty easy. It's not super easy, but it's relatively easy. And there are templates that will help you get started. Okay? All right. So that was expression-bodied members. C# only feature, but so far, unless you have good suggestions for what it should look like in VB, put them up on GitHub, which is where we take all our language proposals these days, and we can talk about it. Okay? I'll take one more, but then we need to get going. We have... When you do this, is there a way to put it back? I don't think Dustin put an analyzer in that will do it for you. I mean, you can press Control-Z. That works fine, but that doesn't work later. But you can, again, it's easy to build one. It's easy to build one. And I'm sure there's going to be, somebody's going to write the better or the more advanced version of C# Essentials soon. They're going to put it up for everybody to download. It's going to have both directions of this. Just like you can imagine having one that changes a var into the type that's there, and another analyzer in the same packet that changes the type back to a var when that applies. Like you can imagine having them go both ways, and they just suggest themselves, and you can choose when to apply them or not. Okay. I don't want to talk more about analyzers now. Is this about analyzers?
Not really.
Okay, good.
Is it possible that you show this in the debugger? I'm just curious how the debugger behaves. If I want to step into something.
Yes, stepping into debug behavior around this. I think you can step into it. You can set a breakpoint on the expression. The thing that we discovered after somebody asked last week that might be useful that it doesn't do today is to be able to set a breakpoint on the semicolon and see what the return value would be. That's a feature we haven't done. We should think about adding at some point to the IDE experience. Okay. I am now going to be officially blind to hands for a second and go on to the next feature. So that was sort of the member declaration level stuff I had. Now let's look inside of expressions more. Let's do string interpolation. So right here, the toString here, which is nice and short, it's still not nice and short enough for me. So let's talk about string.format. It is great. It does all the right things. It has all the expressiveness you need. The one thing that is annoying about it, or other than it being an API call that is somewhat long, is this placeholder thing here, where you have to keep track of the right number, and you have to have the arguments corresponding to it in the right order, and it's so easy to get wrong, and there's no compile time checking if you get it wrong, and so on. So we want to take that away, and the way to do that is to put string formatting into the language with what we call interpolated strings. So what you can do now is to get rid of string.format and replace that with putting $, in front of your string. And now what you'll see is that something subtle happened here. The 0 and 1 turned black. Okay? Why did they turn black? Well, because they are no longer part of the string. When you put $, in front of the string, whatever you have inside single curly braces is a hole into which you can put an expression that is the thing that will get evaluated and toString into place right there in the string. Okay, so if I printed this right now, it would print a 0, 1, because those two expressions would evaluate to 0 and 1, and that's what would get glued in. But if I put x and y there, then whatever value x and y will have will get put into place there. So this eliminates the placeholder correspondence with arguments thing, which I think, thank you. Which I think justifies it as a language feature. You do a lot of string formatting. And for most people doing string formatting, this should definitely suffice. You can actually, if you think about those formatting directives, you can also give inside of the placeholders in string.format format. That still works too. Okay, that just gets passed along. So it's an expression optionally followed by these other things here. Okay, no expressiveness lost on that. The VB equivalent is exactly the same. And if we go to VB, let's look at the toString method over here in VB. You can see it looks exactly the same. Okay, just like the string.format call looked exactly the same. And yet, being in VB, you can also sort of see why we chose the $, because that means string in VB, right? So we kind of, it's a tip of the hat to BASIC, essentially, to have a $sign for string stuff. Okay, there's a question here?
And I assume you can just escape the curly brace if you actually want a curly brace?
Assume that you can actually escape the curly brace. Yes, and the way you escape curly braces is the same way you do it in the format string. We had, along the way, we experimented with different syntaxes, but at the end of the day, we decided it should be as much as possible like string.format, because what you're going to be doing is the next time you revisit that string.format, now you want to change it into an interpolated string, and we don't want to have to do different escaping of curlies and different this and different that. So it's as close as possible, which means that the way you escape a curly is with a double curly, not with an escape slash. Okay, so if I wanted curlies around here, I would do it with double curlies, and you can see it stays red when you have double curlies. That turns into a single curly. All right? There are a few details we can get into about string interpolation. Let's go back to C# and look at this toJSON string method I added here. I actually cheated. I'm actually hard coding some values into there. So it will always print 3, 4, no matter what point you pass in, or point you call it on. We're going to change that in a bit because now we're doing string interpolation. One thing I did want to call out was that you can interpolate verbatim strings as well. Put a $, in front of a verbatim string, that's also interpolated, which means that it now gets angry with me because I have single curlies in there, which gives me an opportunity to show the curlies in C# as well. Now they're escaped, and now I can put little holes here to put the X and Y in. The reason why I'm doing it again here, it's not just to show you show it with the verbatim string, but also to talk about the sort of expert scenario. You have to think about when I toString the arguments and put them in. How do I do that? And the language standard for that is I do it in the current culture. Okay. Very occasionally, numbers, or not occasionally, but numbers and things are formatted differently in different languages. And so using the current culture would mean that formatting a double, for instance, would be different in German than it is in English. Okay, it will show up differently if your culture is German, which is not good if you're trying to generate a machine-readable format like JSON here. You want it to be invariant. And so there is a way in which you can use string interpolation and decide what kind of formatting to apply. And the way that looks, I'm just going to show it briefly. You can only do this in .NET 4.6 because that's the only place that type is present, or you can write your own if you want to. What you can do is to say, instead of saying string here, you can say formatable string. Formatable string. Let's call it FS here. And what you get is so normally an interpolated string is just a string. But if you take an interpolated string and assign it directly to formatable string, it gets target typed. A different object gets created instead. It's kind of like when you take a lambda and assign it to a delegate, it becomes a delegate. But if you assign that same expression to an expression tree, it becomes something completely different. This is the same kind of target typing story, where if you really want it, you can get a formatable string instead of a string out of an interpolated string. And then what you will see is that the formatable string, let's go down here and say fs dot. You see that it has a separate representation of the format string that you would have used for a string.format, and a list. It allows you to iterate over the arguments that you would have had for a string.format. So essentially, you can turn it into a formatable string and construct your own call to string.format with that, with format string and the list of arguments. And that call, you can pass a different culture, for instance. And we also have a helper method on formatable string, static helper method called invariant that will take a formatable string and format it in the invariant culture. So that's what we should really be doing here when we're constructing machine-readable strings that need to not depend on the culture. But that's a very advanced scenario. I just wanted to show it to you that it's here in case you have that problem, in case your German users start to complain, or Danish users too, actually. We also have that different formatting of numbers. Okay. One question there?
Does this all work the same with string builders?
Does this all work the same with string builders? No, this is separate from string builders. You can't use formatable string. Well, no, you can't use it with string builder. A string builder is a way to concoct up a string. It's probably used under the hood when you do your string formatting, but there's no direct interaction between the two. Okay? That was interpolated strings, the easy part, and the maybe not so easy part that you just need to know it's there. I'll take one more question. What's that?
Resources and translation. Old style.
Yeah, the resources where you do globalization or localization with resources. Well, so I guess you could use this for that. The thing with resource strings that are translated, you could imagine writing interpolated strings and then using the format string as a key, or into resources of other languages. But that's a little brittle, because if you happen to change anything a little bit directly in your source code, things go awry. The other thing you might consider is using a translation service directly on the format string, but it gets kind of iffy. It also gives you the opportunity, by the way, to do extra checking on the arguments. Right? So say you want to prevent a SQL injection attack or something like that. You want to only do the formatting if you trust that the thing that you put into the holes isn't malicious somehow. Then you could use the formatable string approach here to look over the arguments before you complete the operation. And because of the target typing, if you have a method somewhere that takes a formatable string, then the user of it isn't inconvenienced. They can still pass the interpolated string, and it gets target typed to that. Just like with expression trees and lambdas, it's the user, the one who passes the argument doesn't get inconvenienced. The one with the interpolated string, it's the one who writes the API that has to do extra work. Okay, enough on that. Let's go and let's make sure that we have some. Let's actually just say toString here, which gives us the right thing. It doesn't give us the right thing, but it gives us something. And let's go and look at a different method here. So this is a method that creates a point from a JSON object in Newtonsoft's JSON.NET. The method checks whether the JSON has the right shape, and if it doesn't, it throws an argument exception. And that's the one I want to focus on right now. We'll get back to this bulk of stuff up here a little later. So actually, I have a green squiggle here. This is Dustin's analyzer telling me that I am doing something that is slightly unsafe here that the new language features can help me with. The problem is that I'm referring to an argument in a string, and that argument may change its name. In fact, I can use the new beautiful inline rename here and call it arg instead, and that all goes well, except that the string, of course, doesn't change. Okay, so I think it's pretty common that people experience that they forget to update the strings that reference program elements. And there's a feature for that. It's called nameof, and we can actually just, if I click the right thing here, and go out of the rename, we can actually go here, and it says consider using nameof. We can go and change it right here. So now there's a nameof feature in the language that you can give any named program element to, and it will return the string of that program element. It doesn't use reflection. In fact, it does it at compile time. So the IL is indistinguishable from the one that was generated from before. This is purely an extra compile time check to see that the string you're giving is actually referencing a program element. Okay? I mean, what a silly little feature. It's like a string literal, but longer, and gives more errors, right? But somehow that's very useful. So of course, let's just try the rename again here. Of course, now it knows which thing I'm talking about, and I can rename it along with the other ones if I want to. There's another occurrence of it actually here. Here I'm saying the parameter is not shaped like a point, so of course we could go and make an interpolated string, put a hole in it here, and then say name of point. So that's an example of, this is not an argument, this is another program element, but you can also take the name of that and put it in here. So if I change the name of the class to something, then that will change the error message here as well. So that's nice. A few details to say, so that's the main thing, and then just a few details to point out, no pun intended, which is that you can also have dotted names in here. So I could take the name of point dot, let's see, get type, for instance. The thing that is a little funny, and what that does is it only gives you get type. It only gives you the name of the last thing in the dotted chain. So you can use the dots to point something out that's further away, but that doesn't make you have to get all the rest of the name. That's just there to tell the name of feature, which thing you're talking about, which thing to rename with, for instance. And what you'll notice here in the completion list is that both the static and the instance members of point are available here. So as a special thing here, even though this sort of is an expression, we do it. Oh, they're here. So X and Y are here as well. So you can actually mention instance members off of the type, because we don't want to inconvenience to have to declare an instance, create an instance and name it of a type just so you can get the name of an instance member. So here we allow both. Okay. Name of is also available in VB. And it looks exactly the same, except, it looks exactly the same, but I'm not going to show it to you yet, because I would give something away if I did. Except that you have the different casing that is VB style, so it's capital N name, capital O of. Okay. That's name of. I'll take one more question on that. Will it work with generics? Yes, it gets a little subtle with generics. You have to disambiguate which generic type you're talking about. So if you say, let's say that you're using list, for instance. You want a name of list. You have to say list of, and then give a type there. Or you have to give type parameters. And that's because generic types can be overloaded on arity. So you have to say which one you mean. Of generic methods, actually, you don't have to, and actually you can't even give you don't have to pick a specific overload, because there the methods are all considered to be part of the same method group, and so you just say the name of the method there. Okay? So there are subtleties around that. Okay, one more. Can you use this? Yes, you can use this. Okay. Enough with that one. I want to get on because I think that it's a mess up here, and I want to do something about it. Okay? The mess is that, I have to check that the JSON object has the right structure. Essentially, if it's there, if it's not null, I want to see if it has an X, and if that's not null, I want to see if the X has a type, and that type is integer, and then the same for Y. Okay? So that I can go and get the X and Y out. But that's a lot of null checking. It's mostly null checking. And so we want to do something about that. And what we've done about it is what we call the null conditional operator, which is that we can put a question mark in certain places, and that will make a more implicit null check. So let's try that down here. I put a question mark in front of the dot, the question dot operator. This is what some people refer to as the Elvis operator, because there's two eyes and there's a swoop of hair. So that's the Elvis operator. What it does is to look at the left-hand side and say, is this null? If it is, then instead of giving a null reference exception on the dot, the whole expression just becomes null. So it propagates the null, if you will. And of course, if the thing on the left-hand side is not null, then we dot in, and the result is the result of the dot. Okay? Null conditional. And when I do this, well, then this line here sort of does the right thing, right? It says it might give null on the left-hand side, but null isn't equal to jtoken type.integer, so it does the right thing, which means I can just get rid of this line of code here, right? Just say, give me the nullable of the jtoken type, and if it's null, fine. Okay? Yeah. Someone there had the right idea, I think, which means I can get rid of some null checks here. The null conditional operator also applies to indexers. So I can actually also, instead of checking if JSON itself is null, I can put it in front of the square brackets as well here. And that means only do the indexing if JSON is not null. Otherwise, the whole thing becomes null. So that means get rid of one more line of code here. And now all the explicit null checking is gone. I just have the core of my logic here, really what I want to stand out, the actual important stuff, which is if JSON doesn't have an X and a Y, both with type integer, then throw this exception. That's all it says, and that's all it does. Okay? That's a null conditional operator. And that one is also in VB. So now let's go over and look at the VB version of this method here. And that is why I didn't want to expand that before, because that would give away the question dot in VB. So you see I have nameof here, just like in C#, but with the proper capitalization. And I have the question dot and the question indexing here. And indexing in VB is indistinguishable from method invocation. So actually in VB, question works in front of parentheses, regardless of whether they're indexing or whether they're method invocation. So let's look at an example where that is, let's take it from a different angle. So in VB, you can conditionally have an invocation of something. Okay? If this delegate is null, don't invoke it and get null instead. We couldn't do that directly in C# because of just syntactic conflict, syntactic ambiguity around the ternary question colon operator. The question mark gets too confusing. So VB has an edge on us here, and VB actually has more of an edge because VB has XML accesses. So if you look down here, if you have an X element, and all the different accesses you can have on an X element can also be questioned, if you will. And that means that they will only happen if the X element is not null. Okay? That should be nice for VB users. And here you see the invocation with the question mark. Now, all is not lost for C# users when it comes to the invocation of null delegates. And a place where you're probably particularly interested in that is around event invocation. Okay? Events can be null or not, and every time you raise the event, there's this annoying thing about what you have to do in order to safely invoke it. So I have to check if it's null before I invoke it, but first I have to copy it because into a local variable because it might change. Someone might call or remove their event handler after I check, but before I call it, and then it will still be null and I will still get an exception. So you have to first do the copying, then do the checking here. But now with the null conditional operator, you don't have to do that anymore. You can't do this with a question mark in C#. This is how you would do it in VB. Just put question mark here and invoke it, and you're done. Check if it's null, invoke it if it's not null. In C# you have to be a little more clever and remember that every delegate has an invoke method that is just normally implicitly called when you call the delegate. And here we're calling it explicitly, so we can do the question before we dot into the invoke method and invoke it. And then that would only happen if the delegate is non-null. So this is now the way that I think everybody should invoke or should trigger their events. No more of that, all that testing around it and that annoying stuff. Just put a question mark dot invoke in C# or just a question mark in VB, and it works the right way. Checks if it's null, calls it if it's not. Yeah? That's got to be in a lot of code bases here, the event triggering. If you have any Any SAML-based? Anybody has any SAML-based stuff anywhere? I would think there's probably one or two. Okay, we can get a little more detail on it. Let's go back to C#. I want to leave it soon, but let's go back actually. Let's go up here and look at this call to JSON string here, and talk about the effect of the question mark. Because we had a big discussion about how exactly should it work, or more precisely, what should not happen if the thing on the left is null? How much should we not do? Okay? And in particular, so let's put a question mark here, just in case points is null. I know it isn't, but let's say it could be. What exactly should not happen if points is null? Okay? Well, the way the language is structured is that, well, this is an expression, and this is an expression containing that other expression, and this is an expression containing that expression. Okay? They're kind of left associative. They build up that way. But that really sucks for the null conditional operator, because if we sort of took that approach, we would say, well, what we're looking at now is an expression that will be null if the thing on the left-hand side is null. Okay, so now this can be null. But then I go dot right into it, and boom, I just get my null exception a little later. Because now I was dotting into a thing that was null. That just became null because of the previous question mark. And so now, to be safe, you would have to put question marks all the way. So we were like, okay, that might be the pure thing to do, the sort of language theoretically slick thing to do, but it doesn't really help anyone. In fact, what you want to say is, I trust that if I get a point, it will never, it never has a null to JSON string. After all, it's a method, right? So you don't want to put a question mark there. So the thing that we chose instead was that there's a list of things after the question mark that will all get canceled if the thing is null, and just replaced with a null result. And that list consists of member access, so dot, of element access, so indexing, and of invocation. Okay, so even though you can't put a question mark directly in an invocation, if there's an invocation somewhere down the line in that list, just like there is here, that too gets canceled, and all the arguments to the indexes and the invocations aren't evaluated. Okay, so you essentially cancel up to the end of a chain of dots, square brackets, and round brackets. Done. And then after that, it becomes null, and whatever other expression it participates in is sort of where things start running again. Things aren't canceled by the null conditional operator. So it's weird when you think about it theoretically, but it does the right thing. It means that you only have to put the question marks right where you think the left-hand side could possibly be null. The null propagates all the way to the end of that chain then. Okay? It's good to know. We had a lot of discussion about it. And we got a lot of community feedback on it back when we were in CodePlex. So that was where the community was really helpful in making us do the right decision, or have the right decision on it. Okay? One last little round of smaller features, and then we'll talk about the future. Is that okay? Yep. So this is going to be more just like a tear-through of some smaller features that we did not add to VB, in certain cases because they weren't a fit, in one case because we didn't make it, and we're really sorry. We just didn't have time. But in most cases, just because they're already in VB. Okay? So here, to JSON, turning it into a JSON object, if x and y, so x and y, you have to assign through the indexers on the J object. If x and y had been members, I would have used an object initializer here. And up until now, that hasn't been possible. But we've now extended object initializers a little bit so that you can now assign to an indexer as well as to a member inside of the object initializer. Okay, so you can just put these right in there, like that, and you don't have to do it in separate statements. Okay, which means I don't actually need the temporary variable. Well, let's see. Here's an inline temporary variable refactoring. Exists, by the way, refactorings in VB, but this is C#, but there are refactorings in VB now. They've never had before. Oh, now there's actually just one statement here with a return statement. So why don't we use an expression-bodied member there? So, hoopla! That's one of those cases where the things cascade together and become really nice. A thing that VB does have and C# doesn't or didn't is exception filters. So I have try, catch, finally here. In VB and in F# actually, you can express a condition directly on a catch block to filter the exceptions that will actually trigger the catch block. So we know it's a repository exception, so we filtered it already by type, but we can also say something. So I just have a bogus thing here. We can say when it has more than 3 occurrences. Or whatever expression we want to put in here. And then we don't even trigger the catch block if that logic returns false, which means it'll keep, the exception will keep going through further catch blocks and surrounding try catches and out of methods and all. It's unaffected by the check if you don't, if it doesn't return true. And that is much better than catching and rethrowing, because catch and rethrow actually changes the exception. It mutates it with the new throw point that you introduced, which means that whoever eventually catches the exception and keeps it and wants to get some useful information out of it about where it started, they will now have the wrong idea of where it started. Okay. So this is better for that. There are also nasty, they're not actually nasty, there's some good abuses of this feature where you can log exceptions as they fly by putting an exception filter that always returns false, but it takes a little note as it sees the exception, because it doesn't affect the call stack. This is a very neat little trick that is commonly used to track how things are flying around. Okay. Another thing that is a catch-up thing that made it into C#, but we didn't have time to do it in VB, is allowing await in catch and finally blocks. We just thought we couldn't do it back in, and we probably couldn't because we weren't as smart back then, back when we did C#5 and VB 12. And so await has not been allowed in catch and finally blocks. And that really sucks, because let's say that I catch the exception here, I want to log the fact that I caught it, so I want to take the repository and say .log, but hey, it's an async method. Okay, I can call that, but now I will, if I call it without awaiting it, then I will fall out of the catch block before it's actually done, before the logging is done. So now I can put an await here. I couldn't before. It's just really just filling out a hole, and I wish we could have done it in VB as well. We will be able to, hopefully later. There's also a close method that is, let's see, repository.close. There's also async here. Okay, what did I do wrong here? Oh, I forgot to give it an argument. There we are. So think about I don't know how many of you have been in this situation. It's pretty commonly reported. Like, one of the points about await is that it allows you to use your normal language constructs around asynchronous code, and try catch finally is a normal language construct. And so it's been very inhibiting that you couldn't just normally do things asynchronously inside of these. People have ugly workarounds because they've had to. Now we have the ugly workarounds in the compiler. You don't have to have them in your code. Okay? Last one, I think. This is just a quick mention. VB has always had this. If you have an extension method called add, for some reason, object initializers don't work with extension add methods in C#. They only work if the add method is an actual instance method. It's just a stupid oversight. And VB it's always worked. Now it works in C# as well. So I can have an add method on iListOfPoint, for instance, that takes an x and a y and adds a point with that x and y. Okay? That's an extension method that I'm totally justified to write. And if I now want to use it here where I create my list of points, instead of saying new point 3, 4 here, I can now use the two argument passing syntax of collection initializers, and that will then call the extension method add for that method. Okay, so you can have shorter initialization here. That's kind of nice. Okay, all right. I am going to switch back to slides for a bit, and kind of kick into future mode, the future of C# and VB. And that's just going to be like a very brief look at what we're thinking about, what's happening, rather. So we started having design meetings for the next versions of the languages. We have joint meetings right now. We do things mainly in the context of C#, but as usual with an eye to it also being applicable to VB so that the languages can continue to co-evolve. And then at some point when we need to flesh out more details, we'll split out and have 2 design meetings, one for C# and one for VB. All the design notes that I write from these meetings, they come out on GitHub. You can see what we did and what we discussed and where we're at. A lot of people also log proposals as issues in GitHub, and that's sort of where both our proposals and proposals from other people live and get discussed. It's a really lively place. Wow, a lot of people don't want to hear about the future of C#. It has one, I assure you. Some of the early themes, we haven't really sort of fleshed out, like this is the list, this is a short list of features. Some of the early themes that we're looking at relates to how much of your code is really distributed programming now, right? You're working against, you have some logic in the cloud, working with other logic in the cloud, talking to a device or to many devices. And so we find that object-oriented programming, while good for many things, isn't always a good fit for that kind of programming, because while the shapes of data are the same that you exchange between these different places, the shapes of data are the same, the functionality is different. And so this whole idea of having functionality wrapped up with the object, virtual methods inside of the class, doesn't work quite so well always, and we want to get better at working with data from the outside, learning from functional programming languages as we go. Talking about wire data, JSON, or whatever comes down the wire to you, people often feel an impedance mismatch between the hierarchical data that comes in string format and strongly typed objects. Okay, you can serialize and deserialize, but what if that thing has some data that is not in part of your type? And how do you hold on to that and reserialize it with the data later if it changed? Or there's sort of a bit of an impedance mismatch there. If you look at the experience in JavaScript and in TypeScript, and TypeScript in particular is an interesting place to look because they have types like we do, and they have a strongly typed experience around this. It is much less full of bumps and gotchas. And we kind of want to learn maybe from TypeScript, maybe from F# type providers or something to bridge the gap better between the weakly typed hierarchical data coming in and going out and the strongly typed writing of code that we love in C# and VB, where we know, the compiler knows the structure and gives you the right IntelliSense and renaming and so on. So that's something to look at. Reliability and performance are also themes that we want to look at a little more. Reliability becomes more important again in a distributed setting. Is my code actually doing what I think it does? Performance, we're running on smaller and smaller devices. Cycles cost money in the cloud. Are the things we can do without turning C# into C++ or a systems programming language? Are there low-hanging fruits where we can give you ways of having better performance where things just suck today? And that's just an overview of themes we're looking at. I can quickly switch to, yes, it's Chrome, it's not IE, because GitHub runs better on Chrome. So if I go to GitHub quickly, give you a tour of the GitHub site, if you will. Here's here's the home page if you want to learn about new language features. So it's github.com/.net/Roslyn. If you want to learn about language features, here's an overview of all the features I told you about and more, and which language they're in. And if you want to get details, this is a C# document here and a VB document. You can go and learn everything that I didn't tell you and everything that I told you as well. If you look at, so for instance, here's a double click down on the C# document that goes into detail with auto properties and so on. Here are the issues filtered by area, language design, and feature request. If you filter on those two labels, you can see everything that people proposed. There are 136 open proposals for language features in C# and VB. So we have our hands full looking at these, but it's also really, really good stuff that comes in from the community. And I encourage you to go and participate there if you're so inclined. Here's filtered for language design notes. We started in January, and they're already, you can see how many language design notes are already up there discussing various features. And if you double-click on that, you can see the ones that we have talked about so far kind of in an overview with links to where they're discussed. So that would be the main resource I would encourage you to go look at. And other than that, well, here's a quick look at some of the specific features just as examples of some things we've been diving into. Tuples, you see the return type up there. It looks just like a parameter list. So trying to use tuples or something to give you multiple return values in a nice syntax. There's another thing we looked at is trying to give you compile time help with nullability. If you could, let's see, if you could say that even a reference type, you could say it was nullable. That seems silly because they're all nullable. But if you said it was nullable, then you're saying it's intended to be null, and we would actually give you a warning on error if you dotted into it without using question dot, for instance. You'd have to use question dot to tell it, I have checked for null. This is OK. So it would help you find those places where null reference exceptions could occur in your code. And then once we've done that, we could say that, well, now it's recommended that you use question mark on all things that could be null, and so the remaining ones are supposed to not be null. And so we could give you maybe analyzers or warnings if you use a non-nullable reference type, the old-fashioned type, if you use that in a way that might make it null. So for instance, if you forget to initialize a field in a constructor where that field should be non-null, we will give you a warning there as well. So that's just a few of the features we've been noodling on so far. I gave you the tour of the GitHub. And I would like you to get a free upgrade, I think. And I would like you to evaluate the session, because we're done. Thank you very much.